All right, so we are looking at 4.3 today, our third type of transformation, and it's going to be a rotation. Okay, a rotation, we know what a rotation is in general, right? In general, a rotation is when you are turning something, but we got to be specific about it mathematically, and of course, we're going to look at it in a coordinate plane today as well. But here's all your definitions about rotation. Okay, all the specifics about rotations here. Transformation, which a figure is turned about a fixed point, called the center of rotation. So every single point on our pre-image is being rotated a certain number of degrees around the center. So we see something like this, and we see our pre-image as this little flag type figure. Our figure, well, it's like a backwards fork. But we take that figure and we're going to rotate it. When we rotate things, the figure itself is going to start turning as well. Okay, we have a tendency to try to think that it's just going to kind of spin around like this, but it's got to spin around. The top needs to go the same number of degrees as the bottom. So you see here the angle of rotation is formed when I connect my pre-image to my center of rotation to my image. It's a 40-degree, in this case, angle of rotation. Now, if I were to do the same thing with, say, these points, okay, if I were to connect that here and then up here, that's also going to be 40 degrees. Every single point, if you connect it back to that center of rotation, connect it to the image, it's going to have that same number of degrees. Okay. So we just got to be careful on that, okay, that every single point is doing that rotating, not just one. We talk about that angle of rotation, right? That's the number of degrees that we have. So that's what we're looking at here. And typically, I would have gone through and we would practice drawing a rotation. But that's a little confusing and not on the test, not on the quiz. And I used to spend 2 days on this. Now we're only spending 1 day. So we're going to kind of combine it down a little bit. So the big thing to talk about when we talk about angle of rotation is that it's always going to be counterclockwise. Okay, rotation is always going to be counterclockwise unless they specifically tell us otherwise. Counterclockwise, of course, for those of you that don't actually look at clocks that have hands anymore. Counterclockwise means we are going this direction. Okay, we're going this direction unless they tell us otherwise. Unless they specifically say clockwise, we have to assume it's counterclockwise. Okay. So a 90-degree angle of rotation would be from here to here, counterclockwise. Okay. And that's going to be important when we start talking about our rules. And I told you on Friday that when we saw those 4 rules for reflection, that we were going to have more today for rotation. And they're going to be very similar to what we saw last week. So when we look at those rules, and we're going to want to copy them down if you haven't already. We've got 3 rules here. And they kind of visualized it for us, right? They put it down on a graph. You don't need to have this. These are the 3 things that you must have down that we can study. All right, so take a minute, write those down, and we'll start talking about it. So like I said on Friday, individually, when you just look at one of these and you're doing one of them, it is not overly difficult, especially when you have your notes in front of you. The problem is going to come when it's quiz day and they say, rotate this 270 degrees, and you need to remember what that rule is. It's not an orange sheet. Okay, you got to know it. And these are very similar to those four that we had yesterday on Friday. Okay, so that is going to be studying. If you need note cards, do note cards, do something. Okay? Do not go into that quiz on Wednesday thinking, yeah, I know it. You got to put some time into the next couple of nights. Okay? Because doing them is not difficult. It's knowing them, it's remembering them, and doing them correctly. And remember, you can always draw it out to visualize to make sure that it makes sense. Okay, rotation here, what we're doing is we're switching, and then our new X becomes the opposite. Okay, 270, we're switching, and the new Y becomes the opposite. And then for 180, you're just taking the opposite of both of them. Okay. So we're going to have to be careful on those. Let's try. Let's say I have a point 4, -2. I want you to tell the person next to you what those three are going to be.
Yeah, 2, 4. 180 would be -4, 2. 270 would be yeah.
All right, so raise your hand for 90. We're going to have for 90 degrees here. For 90 degrees. Parker? 2, 4. There you go. 2, 4. Switch them. My new X becomes the opposite. Okay, how about for 180 here, Jackson? -4, 2. They stay in the same place, but they both become opposite. Okay, and then for 270, we have 270. So we have Jackson who just answered for you guys.
2, -4.
2 and -2, -4.
Oh, yeah.
-2, -4. Because that X value is going to stay the same, right? So that's going to stay the same. That becomes the opposite. -2, -4. Good. And if you have not already, please write down that this is counterclockwise. Okay, put that in your notes. The more that we can pound that in, that's going to be good. It's counterclockwise. So now, just because these are the rules for counterclockwise, does that mean that we can't use them for clockwise? Let's say that I want to rotate something clockwise 90 degrees. Could I use one of these rules if I wanted to go clockwise 90 degrees? Ethan? Yeah, I could use the 270 because 270 counterclockwise is the same thing as 90 clockwise. Okay, if I want 180, it really doesn't matter which way I go. 180 is just half of the circle, right? But if I want to clockwise 270, that's the same thing as counterclockwise 90. So it's just a matter of paying attention to the wording of the problem and which way they want you to go, and then applying the rules that are counterclockwise, just applying the correct one. Okay? So don't be surprised if on the homework or on the quiz you see a question that says clockwise. Okay? That should jump out as a red flag to you. It says clockwise. You just need to pay extra attention to it to know which one of these rules are going to use. Okay? All right, so let's practice it. I'm not going to have you actually graph. I know it's going to say graph. I just want the new ordered pairs here. R prime, S prime, P prime, U prime. After we rotate this 270 degrees. Hey, go ahead, check somebody. So you got something.
Yeah, 1, -3, 1, -5, -3, -5, -1, -2. That's what I got.
All right. Hopefully you got the same thing. First next to you, here we go. We're following that rule. It didn't say counterclockwise or clockwise. Remember, we assume it is counterclockwise. So we assume we can use that rule unless they specifically tell us otherwise. So we have that 270 rotation rule, which is AB becomes B negative A. So we see our points. 1, -3, 1, -5, -3, -5, -1, -2. Okay, questions about our rules in the coordinate plane? Again, it's just be a matter of studying. Okay, just learning. So as you go through the homework, try to remember, right? Try to remember those rules. Try to do it without looking it up every single time. And then if you need to, go back and double check. But force yourself, right? Try to get yourself to do it. Same thing tomorrow with the review. Right? Try to do it without looking in your notes. And then if you need to, go back and figure it out. Okay, where are we at? Another postulate, just like we had with the other two transformations. I didn't have you copy this one down and then say to because we've got it, right? It's a rigid motion. It's not changing size. It's not changing shape. It's just changing location. Okay, so we don't have to worry about that. So we will get into compositions, just like we did with the other ones. So now we could use any different combination of translation, reflection, and rotation. Now it is going to be very important now that we're into rotations and reflections and all of it, that we do the first one first and then the second one. All right, when it was just translations, it didn't matter which one we did first. We would have ended up in the same spot. But I've been trying to get you guys to go in order for sure, because it does matter on something like this. Okay, so here are your points, R and S. I want you to get R prime, S prime after that reflection, and then the double primes after the rotation. Okay, go ahead and try that out. Of course, if you need to, feel free to look back at Friday's notes. Get that rule for the reflection. If you think you know it, good try it. Talk to somebody about it. So you got the same thing here.
Yeah, that's what I got.
All right, so we reflect over the y-axis. When we're reflecting over the y-axis, the y value stays the same. The it's not moving up or down, right? It's just moving side to side. So the y value stays the same, and we switch the x. All right. So what are we going to end up after we take those points, rotate it 90 degrees? What are we going to end up with? Jackson?
We're reading -1, 6, -2.
There you go. Because remember, we're switching them, and my new x becomes negative for that 90-degree rule. Okay, so 3 -1, 6 -2. On big ideas on the homework, they are going to ask you to graph it, right? Because that's what they do. It would end up being that reflection first, and then rotating that 90 degrees. So we end up here. Okay. We will not have to graph on the quiz. Okay. On the quiz, it'll strictly be what are the new order pairs. Okay. That's a lot easier to grade. It's a lot easier to make sure you understand. Okay. So if you need to, feel free to graph it out. Make sure your answers make sense. But as long as you're getting those ordered pairs, that's good. Okay, questions on in the coordinate plane here before we move on to the last thing. Okay. So on Friday, we talked about line symmetry, and we very specifically called it line symmetry, even though we used to just call it symmetry, because we have a new type of symmetry today. Okay, and it deals with rotations. So it is aptly named rotational symmetry. All right, so you see the mathematical definition of rotational symmetry, and we'll look at it so we can understand it. It says a figure in the plane has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 or less. What that means is I can take a figure and I can turn it in place. I can turn it and it will end up looking the exact same. Okay, I turn it some number of degrees, 180 degrees or less than 180 degrees, and it's going to end up looking the exact same. Okay, that is rotational symmetry. The point is the center of symmetry, that's just the center of the figure because you're turning it on yourself. That's the center of rotational symmetry. Since it is considered symmetry, we should be able to do this in either direction, either clockwise or counterclockwise. It doesn't matter because it should be the exact same. So we take a look at something like this, and we see these fans here. And we're looking at rotational symmetry. Right? If we start with this figure, if I take this and I rotate it 90 degrees on itself, it's going to end up looking the exact same. Right? This just turns to here, looks the exact same. If I do it 180, it's going to look the exact same. If I do it 270, it's going to look the exact same. Right? 45, does it look the same? No, it doesn't look the same, right? Now it looks different. So 45 degrees is not an angle of rotational symmetry. We would be able to rotate it 90, we would rotate it 180 to 70. Okay. So the two things that they're going to ask here, well, the book's going to ask very specifically for the possible angles of rotational symmetry. Okay, the possible angles for rotational symmetry. So this would be 90 and 180 and 270 if that's an option. It's going to be a whole big multiple choice. You got to choose which number of degrees will make it look the exact same again. Okay, what we're going to ask for on the quiz, on the test, we're going to ask for two things. We're going to ask for the angle of rotation. And the angle of rotation is going to be the smallest number of degrees we can turn it before it looks the exact same. So when we ask for angle of rotation, I don't need 90, 180, 270. The angle of rotation for this one would be 90 degrees. That's the smallest number of degrees I can turn this figure and it will look the exact same. And I can keep turning it 90 degrees. And every time I turn it 90 degrees, it will end up looking the same. Okay, that's our angle of rotation. Is how many degrees can I turn it so that it looks the exact same. The other thing that they're going to ask for is called the order of rotation. And the order is not necessarily what we would think the word order means. The order is how many times can I rotate it before it gets back to the original. Okay, so this is how many times can I rotate it before it gets back to the original. Well, if I have, let's say this point starting here, I rotated 90 degrees, that's once, twice, 3 times, 4 times. I'm going to rotate this 4 times before it gets back to the original. So the order of rotation for this figure would be 4. I rotated 90 degrees, my order of rotation is 4. So I can do that 4 times before I get back to the original. Let's say I have a rectangle. Now, the person next to you, what's the angle of rotation going to be, and what's the order going to be? Okay. Okay, so how many degrees do I have to turn this before it looks the same? 180. Okay, that's a 180-degree rotation that I would do to make it look the same. Why wouldn't it work for 90? 90 doesn't work here. Jackson?
Like up and down.
Yeah, it'd be up and down, right? It's not going to look the same. If I did it 90, it's going to look like this. That's not the same, right? So we got an angle of rotation of 180 degrees. What would the order? How many times can I do that before I get back to the original? What's it? 2. Order is 2, right? Because I can rotate it once to get here, rotate it a second time, it's back to the original. Somebody raise your hand and tell me, what relationship do you see between the angle and the order? Ethan? Yeah, it's got to equal 360, right? Because 360 is going to take us back to the original. So whatever that angle of rotation is, and whatever that order is, I got to multiply those together. It needs to equal 360 degrees because we're taking it back to the original starting place. Okay, so the angle and the order need to multiply together to equal 360 every single time. Now, the book's not going to ask you about the order, okay? And I warn you about that because you're not going to see problems on the review or on the homework tonight asking about the order. The quiz will ask about the order. The reason why is because the book that the high school still teaches out of talks about the order, okay? And we need to be doing the same stuff they do, so that's why we add that in. So make sure you know the order because that will be on that quiz. All right, so let's look at rotational symmetry here. Talk to somebody about it. Parallelogram, octagon, trapezoid. What do we have for rotational symmetry here? Angle and order. If any.
Yeah, but then it would have to be 1. And a trapezoid is
all right, for our parallelogram, what angle do we have here? How many degrees before we get back? Riley?
360.
Nope. Jackson?
180.
180. Because 180, what 180 is going to do is it's going to take this point and it's going to put it here. It's just going to rotate it 180 degrees. So this figure is going to kind of rotate around, right? It's going around the center. So this is going 180 degrees to get here. This is going 180 degrees to get here. It's going to look the same. So that is 180, which means our order is 2. Okay, so that's a 182. What about our octagon? What do we have here, Parker? That is 45 degrees. Okay, 45 degrees. What's the order for that? How many times is it?
8.
8 times. It's an octagon, right? If it's a regular octagon, it's going to be 8 times because I'm taking this one point and I'm rotating it to get here and here, right? I'm rotating. Every time I rotate it, it's going to move to the next spot. Makes a nice little flower. So that's an order of 8, right? And 45. Let's say we know that it's an order of 8 because it's an octagon, but we don't know how many degrees. 360 divided by 8, right? Because we know those have to multiply together to give me 360. So if you know one of them, just divide 360 by that, and you can get the other one. What about the trapezoid? Here, Eddie?
360.
Yeah, there's no rotational symmetry here. So we wouldn't even say 360, we'd just say none. Yeah. There's no way to turn that on itself until we get back to the original. So there'd be no rotational symmetry for that. All right. Any questions about rotations, rotational symmetry, anything like that? Make sure we've got angle in order. Okay. All right.